We are Jinwell Timothy D. Canalita,
Adrian S. Avila,
and Jonas Shiskasi Makanang.
and we are proud to present our research project entitled Brewed Bricks, Coffee Husk-Based Eco Blocks for Heat and Sound Control. Our study focuses on finding an eco-friendly and low-cost building material that can help reduce heat and noise, especially in classrooms and homes.
Heat and sound greatly affect human comfort, health, and learning performance. Excessive heat can cause discomfort and poor concentration, while continuous exposure to noise can lead to stress and reduced academic performance. Most conventional insulation and soundproofing materials are expensive and harmful to the environment because they require large amounts of energy and resources to produce. Because of this, our group explored the use of coffee husk, an agricultural waste material that is usually thrown away or burned. Coffee husks are lightweight, fibrous, and porous, properties that make them suitable for thermal insulation and sound absorption.
This study aimed to answer the following questions. 1. Can coffee husk-based eco blocks reduce heat transfer compared to plain blocks? 2. Can coffee husk-based eco blocks reduce sound intensity compared to plain blocks? 3. How does the combined heat and sound control of coffee husk blocks make them unique compared to existing studies? The general objective of the study is to determine the effectiveness of coffee husk-based eco blocks in controlling heat and sound. Specifically, the study aimed to 1. Produce eco blocks using dried coffee husks and cassava starch as a binder. 2. Compare the heat transfer of coffee husk blocks and plain blocks. And 3. Compare the sound reduction capability of coffee husk blocks and plain blocks.
This study is significant because it promotes the use of agricultural waste materials in creating sustainable and eco-friendly construction alternatives. The coffee husk-based eco blocks can help reduce heat and noise in small spaces such as classrooms and houses while being low cost and environmentally safe. Additionally, the study enhanced our understanding of heat transfer, sound control, and scientific experimentation, while encouraging environmental awareness and innovation among students. The study followed 5 main steps. First, eco blocks were prepared by cleaning and drying coffee husks, mixing them with cassava starch and water, molding them into uniform blocks, and sun-drying them for 2 to 3 days. Second, plain blocks were prepared using only cassava starch and water molded into the same size. Third, for heat transfer testing, each block was placed between a heat source and a thermometer. Temperature changes were recorded after 5 minutes. Fourth, for sound absorption testing, sound intensity was measured using a mobile phone sound level meter. Finally, all data were recorded and the mean of 3 trials was computed for accurate comparison.
Based on the findings, we conclude that coffee husk-based eco blocks are more effective than plain blocks in controlling heat transfer and sound intensity.